So I've been showing you demos in our lab, and now I'm going to introduce you to some people who work for one of VMware's customers, Neurothink.io. Neurothink is building a business providing machine learning as a service, and they use vSphere with Bitfusion and Tanzu Kubernetes to provide that service. If you need more GPU power for machine learning and you want it easily accessible, Neurothink.io will be offering clients efficient and secure development and training environments to do their best model development work. Here is Brian Rogers, CEO of Neurothink.
Thanks, Earl, and thanks for having us Neurothink come speak about the platform and our Bitfusion implementation. Today, our team will be demonstrating how we leverage Bitfusion and the power of a radically accessible machine learning platform with our 4 petaflops of enterprise-grade GPUs. This moment has actually been almost 2 years in the making for us. What we mean by radically accessible refers to how quickly and easily a data scientist can spin up a project, select a required compute resource, and train the best possible models. One of the key components to our platform is its ability to maximize the utilization of these GPUs, which you saw earlier in Earl's demo. For many years, companies have been fractionalizing CPUs, but now we have the ability through partnerships and a complicated software stack to be able to fractionalize GPUs, which allows for a larger group of users, from corporate data scientists to university students, and even hobbyists. To address the many current day frustrations with these fragmented environments and inefficient GPU access, we designed our platform first and foremost to be a machine learning platform. Based on months of interviews with our data scientists, we saw the opportunity to build a more efficient and innovative workflow for AI ML projects. This required that we start at the hardware layer, our own servers, storage, switches, etc., CI/CD, architecting a full middleware layer with partners like VMware and NVIDIA. And finally, we added a custom innovative UI UX, which I think that you'll see in the demo, you'll see is very different than what you may have seen with other platforms. This allows us to support features like no plugins, staying in one environment, real-time monitoring, and built-in experiment management. So first up, you're going to be hearing from Charles Donnelly, our COO, who has had a diverse technical career, which has included building models for the computer hardware industry. I think it's also pretty cool that he started his career actually as a nuclear physicist, designing nuclear reactors for the Navy. You'll see that Charles has a very deep and broad understanding of machine learning, so he'll dive a little bit deeper. Charles?
Thanks, Brian. It's great to be here. This has taken, as Brian said, nearly 2 years building out the team, building out the infrastructure, and today you're going to see a live demo of our platform. This is all of that massive GPU compute power, along with the virtualization, along with the VMware automation, and the rest of the stack that we've put together, sitting in a co-location facility in the middle of the US, accessible to most cities in the US in under 30 milliseconds. It's just fantastic that this type of resource and availability is here in this day and age. But we want to make it radically accessible to everybody. And we're going to describe here 3 of the ways that Bitfusion has helped us to do that. First of all is getting a large number of people onto our platform. So we do that by fractionalizing the GPUs. You want to get into your development environment. We don't want to charge people by the minute there. We want people to be able to stay as long as they need to in their Jupyter notebook, in their CLI, to do their best work preparing to be able to train the model. And with Bitfusion, we're able to do that. We're able to break up our GPUs down to 1/40th of a card. It's just fantastic. And that's all done automated. The next thing is when you're in Jupyter Notebook is the ability to attach to the Jupyter kernel. In fact, this is so seamless that we're going to have to stop, and Jordan, our data scientist, and Akhilesh, our virtualization expert, are going to have to walk you backwards and show you what's going on in the background, because we get into one environment, the GPU's attached, you're in your Jupyter notebook, nothing that you have to download on your side, nothing you have to read about, don't have to be switching windows. It's really just a great seamless experience to be able to get in, work on machine learning, build and train your best model. Finally, once you're ready to train that model, access to Volta and peer level GPUs and just the amount that you want, we can dynamically attach in the same environment. So the great news about that is you finish with your Jupyter notebook, we roll up that code into Python, and we're able to attach the new GPU resource you want, pay for just the amount of time you're using it, go do your training, get done with it, review the experiment. What did I like? What didn't I like? Get back into your development environment and do it until you're happy that you've got your best model. That's part of the experiment management we offer. But most exciting is going to be seeing the actual platform and letting Jordan and Akila show you that. So Jordan.
Thanks, Charles, and welcome to the live demo portion of our presentation. So if you'll allow me to share my screen. Here is the login page for our platform. So on this page, you can see how our platform is powered by Bitfusion to offer our radically accessible machine learning platform. So our platform is designed to get people in as quickly as possible. And so here I'm going to show you how to log into our platform and get in and get started right away. So here we've logged into our platform, and here you can see all of the instances created on our platform. So on our platform, we have two notions of objects. One is a project and the other is an instance. So a project is some sort of data science project that you want to work on. So for example, your project might be working for the local county, detecting potholes. And so you might need to tackle this problem in a number of ways. So you build an instance to tackle this problem each different way. So for example, you might want to do some sort of pothole detection. You want to know where in your images you have potholes. And then you go through a pothole classification. Is this a deep pothole? Is this a shallow pothole? Is this pothole something that needs to be covered up soon? Maybe we want to mark it for later. And maybe you have different data sets that you need to identify potholes on. So for example, winter pothole, summer potholes, etc. And so this is just to show you different ways you could use an instance to create your project and solve your data science problem. Today, I'm going to show you what we've called our VMworld demo. And so in this, I'll show you our development environment, which is a Jupyter notebook, and it's powered by Bitfusion. So you're actually seeing here a Jupyter command, a Python command, and in the background, we're running this through a T4 GPU, or at least a fraction of it. And then we build our data science workflow. And so here I've made a simple regression model just to predict the prices of the housing market in Boston with XGBoost. And so that will take use of our GPU to do that. So let me show you our GPUs in the background so you can see what these Jupyter kernels look like from our command line interface. So here you can have our terminal window, and we can show you as an admin of our platform all of the GPUs in this particular environment. So you can see a number of the GPUs on this server. The T4 server are taken up, but just a fraction of them, which allows us to get a number of users onto our platform and developing their data science models using GPUs. And I'm going to let Akhilesh show you this from the Bitfusion perspective.
Thank you, Jordan. Now, just to validate what we have seen in the CLI that Jordan just shared, here is the pool of GPUs that we virtualized using Bitfusion. Here we have one T4 server and the two A100 servers, aggregating to a total of 20 GPUs that are currently available in the Bitfusion pool for allocations. Jordan.
Awesome. Thanks, Akhil. And so now that we've shown you all of these GPUs and how they've been allocated for our different Jupyter notebooks in the Jupyter kernel, we've built out our data science workflow to train a simple model. What we actually want to do is go ahead and train it. So here's where you're going to pick your training resource. So if you want to just train on CPU, you're welcome to do so. Or if you want to use a GPU, we have Turing, Volta, and Ampere GPUs, which are the latest cards from NVIDIA. And so say you want to use just a fraction of an A100 GPU. Maybe it's not a very big model. You can do that. So here we've got a package set for 16 gigabytes of an A100 GPU, which is going to take up 40% of that card. So here we can click use this training processor. And then you see that the processor is attached successfully. and then we can click ready to run, and this training will kick off. And then you can see that TensorBoard pops up, and it'll show you the metrics of your training run as it evolves. And then I will let Akhil show you this allocation from BitFusion.
Great. Thank you, Jordan. Now, to see where the GPUs are being assigned from to the job that Jordan is running currently, if you pay close attention here on the first BitFusion server in the GPU pool, this is a fractional GPU of 0.4. This is the server where the GPU has been allocated from. We can also validate this from the client's view by going to the client's tab here and see the assigned GPUs from this view. So you see the 0.4. This is the 0.4 of one GPU. So that is the beauty where we can allocate just 0.4 of the bit of the GPU to this particular job, and the remaining to any other job that that is needing the GPU resources. Back to you, Jordan.
Awesome. And thank you, Akhilesh. And then finally, maybe you have a really large model. And so just a fraction of 800 GPU is not going to cut it. So you need to use multiple GPUs. So we can do that as well. So here we're going to use 128 gigabytes of an 800 GPU, or rather 4 GPUs, which is going to assign 32 gigabytes to each card across, again, 4 different GPUs. And so we can attach this training processor, click ready to run. TensorBoard pops back up again, and we can see this.
Thank you, Jordan. Once again, if you observe here, what we'll be seeing, what we're seeing here is the multiple GPU allocations. We're seeing that from the second BitFusion server again. So here we have assigned 3 GPUs to that particular job run. And once the job is completed, we can also go to the client's view here just to make sure which client has received those 3 GPUs right here. So, and we can see the GPU allocation here. So once the job is completed, the GPUs are released automatically and added back to the BitFusion pool for the next job runs to use them. So as mentioned earlier by Earl, this is how we are leveraging BitFusion on our platform for efficient and effective utilization of GPU cycles, and in turn, helping the AI/ML user base get one step closer to radically accessing the currently highly priced GPU resources on demand. Jordan.
Awesome. So now that we've shown you how to train a model through our platform using different types of GPUs and different levels or different amounts of GPUs, we can show you just a quick sneak peek of the experiment management section of our platform. So here you can see all of the instances created on your project. And so you can see all of the pothole detection instances, as well as this VMworld demo instance, and some of the metrics that have popped out via training through TensorBoard and some of the other logs. And so this will allow you to compare and contrast your different instances that you've created, as well as the models inside of them. And so finally, I'd like to show you our tree view, which is going to show our customers the parent-child relation between all of the different instances they've created. So you might create an instance V1, which detects potholes, and that didn't work very well. It was a good start. You create then V2, and then on V2, maybe you realize you didn't have the full data set, so then you go to 3A, and 3A didn't work very well, so you go back to V2, and from V2 you spawn out 3B, and so in this way you can track the origin and the results of all of the different training runs that you've done through all of the different instances that you've created, and have a whole history that you can look through to see when all of these models ran, how did they run, how can I go back to it and I can launch it, and then I can see exactly how I trained the model, and I can use that model for maybe deploying or for a live production environment. And so this, we think, is going to really help data scientists manage their experiments and manage all of the training runs that they do on our platform. And so that's all the things that we wanted to show for our platform today. And so I'm going to pass back to Charles, and he's going to tell you how you get access to our platform.
Thanks, Jordan Akalesh. It's awesome when a live demo works as well as that did. We're super excited about this platform. This year, 2021, we're going to have limited access to the platform. If you're interested in that access, please contact us at info@neurothink.io. If you want to know more about our company and what we're doing, visit us at neurothink.io. We're also on social media, as you can see down below. In addition, at the end of Q1, beginning of Q2 2022, we'll have our first public release, and we'll be very excited to get those features rolled out, get user feedback, and continue to make this journey radically accessible.